Example 1 says solve the following rational equations. Be sure to state your excluded values. I like to do those first. I'm kind of apt to forget if I don't. So to check for the excluded values, we know that the bottom of a fraction cannot be 0. So this first one, w, cannot be 0. It can be any other value. There's many different ways to solve these. With this one, I think I'd like to multiply by w on each side. So we've got negative 5w is equal to negative 3. And then we'll divide by negative 5. And w is equal to 3/5. Notice how this value we get for w is not 0, and so we're okay with that value. The bottom here of this fraction, the denominator, cannot be 0, so we know that y can't be negative 6. Even if we find negative 6 to be a solution, we know that it actually can't be that value. As we solve this, I think I'm going to multiply each side here by y plus 6. So we have negative 4 is equal to, using the distributive property, 6y plus 36. We'll subtract 36. 6y is equal to negative 40. And then divide by 6 here. So we'll simplify this to negative 20 over 3. The next one, we only have this one part of this fraction. Notice how 7 over 5 is just 7 over 5. It's just that this fraction, x, cannot be equal to 0. Even if we find that as a solution, we're going to have to ignore that. There's a few different ways that we could work with this equation. I'm going to choose to multiply everything by 5x. So you can multiply the denominators together, and that's a really good thing then to multiply each side. So 4 times 5 is 20, we'll have 20x. On the right side, I'm going to have 7 times 5x over 5 minus 2 times 5x all over x. So if you can multiply by that, by this denominator and that denominator, you'll find that you're going to kill those fractions. So we have 20x is equal to 7, there's an x there, and then minus 2 times 5 is 10. To solve this one, we'll subtract 7x on each side. 13x is equal to negative 10 divided by 13, and x will be negative 10 over 13. That's not 0, so we're okay with this value. It totally works.